I'm Pascal Leray from France. I'm living in south of France and I'm a doctor engineer from the University of Paris. I design and build myself this pipe organ without any grant. And I design for this organ several things, hardware parts, hardware boards, and also two software modules which are called organ controller, which can control this organ, and organ designer, which is able to conceive and to design new organs very fastly and very cost-effectiveness. So I show you now software designer, which is I wrote for creating wind chest automatically. This software receives in input the dimension of the pipes, and it's only a file which I can open here. Here you can see the different pipes for several registers in a wind chest. You have the diameter, the width, the height of the pipes, and one can change the position of each pipe here. And also the originality is that you can see this wind chest in 3 dimensions. So you have an aspect you can see on watch your chest before drilling. Because the main interest of this software is to automatically drive a machine tool which can drill for the boards, the different boards of a wind chest. You can see also another complete organ with several chests like this. Here you have 3 wind chests here. So you can see an aspect of the organ before creating the wind chest. I use all this software for all the wind chest I built in this organ. In input, at the rear of the keyboards, I designed this board, which is directly linked to this interface, which can receive here up to 8 keyboards. And this board is directly linked to a standard parallel interface, which can be received by any PC. For output, for the control of electronic magnet valves in the organ, I designed this board which can drive. Here I have 4 connectors, and I can drive any number of registers with this board. Here I don't have Darringtons, and here this board can drive 64 outputs, and here 236 outputs, magnet valves. For example, I'll show you this magnet valve, but any kind of magnets can be used. With the second board, I can drive up to 7 amperes per output. So with my software controller, any kind of PC can be used, even very important desktop computer, laptop computer, or also very small boards, but very efficient boards, such as this dual-core PC, very cost-effective PC, whose cost is about $100. So my software with the 3 parts, these parts you have seen before, the software designer, the software controller, can present very cost-effective solution for organ builders. Here you have the input boards, which are placed at the rear of the keyboards. Here are sensors, all sensors, and magnets, and sensors and sensitive to the magnetic fields. And you have little magnets here. And when the magnets are just behind the sensors, it state change, and it sends information to the PC. One can use indifferently digital or analog sensors, and so you can have sensitive, expressive pipe organ. So you have here the keyboard, which is linked to the pipe organ I built. And any keyboard like this can be, any MIDI keyboard can be linked, can be plugged on my software on my PC. The important thing is that one can control the number of registrations. Here I have constant sound. I can change the sound. But if I push this button, I'll change dynamically the registration. So if I hit the key slowly, I have a sound with only a button, and if I hit faster, you can hear the difference. So for an illustration, I can play anything. So with this system, you can control both the registration and the keys dynamically. So it's an expressive and sensitive pipe organ. I'll show you now a software controller, which is a software which controls all the stops, the registers, inputs the state of the keyboards, and outputs and controls the boards I showed you previously. So here I have nothing, and I can hit one virtual draw stops, and I have sounds in 8 feet or 4 feet. I can also increment or decrement the number of registers, the registration. After I have the reeds. So all the stops can be used on each keyboard. You have the different keyboards. And here the state in 4 feet, 16, 4, 8, and 2 feet for each register. I can reset all the stops here, so increment. I have also another facility for the tuning of the organ. I hit Control V on my keyboard, and here I can have one stop, for example, here, or the trumpet. If I want to tune the trumpet, or another stop, such as Preston, Montre, Nazart, and so. So it's very easy to control and to tune the organ without the help of an assistant on the keyboards. Another functionality is the possibility to transpose the frequency of the main frequency of the organ, like this. So I choose registration. And I can So it's very interesting to have this functionality because it's not necessary to transpose with this brain, but a little part of program. It's due to it's very easy to develop and to customize the software for each functionality and for each organist or organ builder. I have another possibilities such as MIDI, so it's here the control of the keyboards remotely. Here is a MIDI read automatic, and you have also the mixture which can be edited directly with this screen. And here is the envelope curve. I can define a registration, a changing registration. Also, I have a pedal here for expressive pedal, and I'll show you expression. You can notice that there is absolutely no sound of real stops, real draw stops, but as this organ is a unit organ, it's possible to change the registration without any noise. So here is the source code of software controller, organ controller software. I have about 100,000 lines of code. But it's very easy to change. I have modules for output, for input keyboards, MIDI output, MIDI input, and also for power control of the board I showed you previously. So here you have some examples of parts of the codes, but it's much more simple to develop using C++ on PC, on standard PC, than developing software for microprocessor like this. Here is a simple board which has in input 64 entries and in output MIDI output here. But it's not used here. All the board I showed you previously don't use this board. I have only input boards, output boards, and a software, this software controller.